I'd like to
Go
introduce
ahead.
Ed Fong. I think a lot of you know the name. Uh, Ed's was licensed in 1968 as WN6IQN. He later upgraded to extra class and even did the 20 words per minute, as some of us old timers had to do. His present call is WB6IQN. He got his bachelor's and master's at University of California at Berkeley and his PhD at University of San Francisco. A life member of the IEEE. He's got 12 patents, over 40 published papers and books in the area of communications, integrated circuit design. Presently, he's employed at the University of California, Santa Cruz, previously at UC Berkeley as an instructor teaching graduate classes in antenna design. So I have a personal connection to Ed. Turns out that we went to the same college and we're in the same class, graduated. So I'm not sure I remember him in the coffee room, but anyway, Ed, thank you for joining us this evening, and I'll.
Hey, point the camera to you. I'm trying to see if I can remember you.
Yeah. Hello, Ed.
Uh, I can't say.
I was the tall, skinny guy.
Yeah, I can't remember. No, I can't say I remember you. Sorry.
Yeah.
Anyway,
All right.
let's go on.
Okay. So I'm going to stop sharing, Ed, and then if you can, I presume you've got a presentation you want to share.
Right. I'll share. Make sure you give me the share screen ability.
Yeah. Okay. You should be able to share now.
Wow, you guys got quite a group, huh? Wow, 26, and then there's quite a crowd in the room there.
We're all looking forward to your talk.
Okay, so let's see. I'm going to see if I can share the screen here. Oh, I could. Very good. No, that's just one. Okay. And then I do this. There, you see that, right?
Yes, we do.
Very good. We're all set then. Okay, very good. Thank you, Ken. Yeah, apparently you're in the same, you graduated in 77?
Yeah, 77.
Same grade, same year. Oh,
Yeah,
nice.
that's something.
Huh. So did you know like Lark Reberg?
No, I don't know Lark.
Oh, huh. I'm sure we ran across each other in the coffee room, in the Moore room.
Probably did.
Anyway, other folks don't want to listen to our old stories. You want to hear this talk. Anyway, hey, thanks a lot. Thanks a lot for the introduction. So I think a lot of you folks probably have my antenna. The audience there in the room, how many of you folks have one of our antennas? Oh, good. I only see 1, 2, 3. Oh, that's not too many. Good. I can still afford to sell some afterwards and raise some funds for my group. All right. So oh, and you know what I need? I need a cup of water. Just hang on. Okay. Now. So what I'm going to talk about is most of you probably have the DBJ1, which is our dual band VHF UHF base antenna. You might even have our roll up. So we'll talk. I see. Hang on here. We'll talk about the original one, which is the article published in 2003. We had a roll up one in 2007, and then we have a tri-band. And those are subsequent talks that I'll give on that if you like, and I'll be more than welcome to just schedule me in. And these antennas I'll talk about, they're pretty well established. They're in the ARRL now, in the ARRL handbook. They're in the Antenna Classics, Antenna Compendium Volume 8, and Antenna Compendium Volume 3. So they're pretty well accepted design. The ARRL has at least 2 models of every one. They usually require that if you could build it and send it to them. So they've confirmed these results. And I say, if you get one of my antennas, you can't get these same results, you're doing something wrong, because the ARRL has tried it. Okay, so on the right-hand side, that was the original article back in 2003. This is the roll-up version of it. Actually, a couple of years later, a lot of people saying, hey, it's a really good, clever idea. Is there any way you can make it a roll-up portable? This is the results of it. And then we also made a tri-band years later, FEMA kept on saying, hey, we would love you to make a 2-meter, 220, 440 antenna. All in one. We would like it all in a requirement. So what do you want? We want it all in one like that's in a pole. No radios. And I said, and no DC lightning arrestor, because that's an extra $50 they were paying for. So I said, well, let me see what we can do about that. And we worked on it, and we came up with this tri-band antenna in 2017. So they'll do 2 meters, 220, and 440. J-pole design. So it does. Whenever you use a J-pole design, you don't need a lightning arrestor. It's a DC short. All the J-pole designs are DC short, so it can't hold charge. And I'm sure the lightning arrestor people don't like that. I mean, I've had to convince ATD alarm systems, because they use thousands of antennas, and they were using lightning arresters. I says, well, if you use a ground plane design, you would need a lightning arrestor because it's a DC open, so it can hold charge. If there's a lightning storms close by, it can induce, lightnings millions of volts. So even if it's a mile away, you can considerably induce just by magnetically. It doesn't have to resonate magnetically like a transformer. You induce 40 volts or so, it goes right down to your antenna and blows out your front end. So there you would need a lightning arrestor. Then a ground plane design, because it's open circuit. But J-poles are really nice because it's a DC short, so it can't hold charge. So you really don't need a lightning arrestor. So automatically save $50. Lightning arrestors are about $100, and you only pay $150 for an antenna. That's a lot. That's a good portion of it. So it's clever that engineers have just kind of designed this out. We've had a few patents on it, and I'm not a patent guy really, but it turns out that the first one we did, people started copying it and selling it, and also people, and I guess they maybe had the right to say, here we are selling you the Fong antenna as it appeared in QST. They copied it and started selling it and saying it's our antenna, but it wasn't from me. So the university, Mike Kaufman was the attorney here, says, no, you got to patent these things. They are pretty clever ideas. I just didn't think of it. I usually think of patents as stuff I do at work, C circuits and things like that. But he says, no, these are pretty cool ideas. So later on, when we came up with the roll up, we couldn't patent those. Same thing as it's very similar to the regular dual band I'll present today. But later on, we came up with a really cool collinear design to get gain out of a J-pole. We patented that. And of course, the tri-band was very clever. We patented that. The disadvantage of a patent is that you got to pay about $5,000 to do the research in a patent and get the attorneys to write it up. And so you got to make sure it's worth your while. And in our case, I think it was. But you just don't go. Some people write their own patents, which is great. If you can write your own, then it doesn't cost you. It's just a filing fee. But if you don't write your own, and I'm not about to use time to write my own, it costs $4,000 to $5,000. So you got to make sure you can get your money back. Okay, so here we go. Why do I like the J-pole? When I looked at this, 20 years ago, the J-pole is actually a pretty cool design. It doesn't require radios, and I'm sure a lot of you folks have versions of the J-pole. Top row J's, roll-up J's like what we have here. There's all kinds of, basically the J-pole configuration, but you can implement it in several ways. The thing I like about it is J-pole has no radios, so it doesn't have anything sticking out. And when you have things sticking out, what I found is, I grew up using ground planes. I think a lot of you did. It's like got on 2 meters in 68, 69, and yes, what are you using an antenna? I'll go make an antenna out of a ground plane. What do you know? I'm 12, 13 years old. Sure, okay. And we used this for a while and it worked. It turns out that's not the greatest configuration. That's why you don't see them anymore. The J-pole actually is much more closer to an ideal dipole. And if you've ever looked at a ground plane with radios compared to a J-pole, the J-pole would actually give you about 1.5, 1.6 dB of more gain. That's not major, but it's every little bit helps. But I like it because it's unfed. That means you don't have radios here. Let me show you. The J-pole design, and I think if you guys have been hams a while, it started gaining popularity maybe 20 years ago. Now it's just standard, right? You don't see that many ground plane type configurations anymore. And I took this picture a few years ago up at Mount Sutro. If you guys are familiar with the Bay Area, it's basically Twin Peaks in San Francisco. It's the peak right in the middle of the city, which is an interesting city. You got this peak, great for antennas. This is their main tower, which has both commercial stuff, two-way radio stuff. that looks like a broadcast antenna of some kind. I feel sorry for these guys out here, man. They must need some pretty good filters to filter out that, because that's a broadcast FM station. It's got to be a lot of power. But what's more interesting is look at these antennas. I don't see any of them with radios anymore. Now, I didn't take a picture 30 years ago. I wish I would have, because I remember growing up there as a kid, and a standard antenna was some kind of based on a ground plane, and then you build on that. You could see there's radios. There's no radios on these. That means they're using some, I think most of them will be using some type of a J-pole design, which means it's a DC short. It doesn't require a lightning arrestor. That's interesting. It's really phased over. And I talked to people in two-way radios. Says, oh yeah, we use all basically start with the J-pole design, work from there. But the idea that it doesn't require radios is really advantageous. When you sit in a tower like this, winds 60, 70 miles an hour, you think that thing's sticking out like that. It's not good. It'll blow away. And, I usually give this example real quick. I could grab an antenna here and I'll show you. Here, I got one here. Oh, you look at an antenna like this, and you guys are probably familiar with it. I can hold it up vertically very easily. It's just vertical force. A radio has a horizontal force because it's slanted. And you guys can, you just common sense say, if I start slanting this, it gives you a horizontal force. That's a lot harder to hold up, much, much harder. So you can imagine a radio, 3 radios sticking out over the years. Maybe UHF might be acceptable, but VHF, it gets 18, 19 inches over the years, it'll break. It will break unless it's made of super steel and it's welded together. So yeah, most don't have radios, and then to go up and repair an antenna like that, that's, believe it or not, it's about a $500 job now to go up there. It costs about $500 to do something to an antenna in a tower like that, and it's high risk. They do a whole plan for it. You've got people on the ground. Got to get a permit, and it's a big process because it's pretty dangerous to go up there. That's why people don't fall off. You don't hear people dying. So they go through all a safety procedure and all this stuff. So it's not cheap. So that's why when you want that antenna up there, you want it to last long. Okay. So here we have an antenna that we used to use. It's a vertical dipole, conventional dipole. Not a bad antenna. It's quarter wave up and quarter wave down. You don't see the little Teflon insulator there, but there is one. What's the problem with the dipole? It works fine. But the problem is feeding it. You got to feed it at 90 degrees so it doesn't interfere with the pattern. And the further you get this arm out, the better it's going to work, because you always have a mass. If it's conductive, it's really bad, like this one. It's going to act as a reflector. Even if it's non-conductive. And it's hard to do when they're really tall, right? It's pretty much all conductive, copper or steel or something. You got to get this thing further and further out. The more further out it is, the less it will see that mass. But that's contradictory. The further you move this out, the more torque is going to be right there, right? If you're a mechanical engineer, it's R cross F, right? The force at this node is R cross F. It's the force, but it gets multiplied as you go out in distance, right? If that force was here, it's not so bad. It's a vertical force. But as you go out, you have to multiply R cross F. R being the distance. So if you're going to get this thing 3 or 4 feet out there, trying to hold that right there, you try to hold it with your arm, that's pretty tough. And you think about all the wind, and we've tried these, think about all the winds up in the mountain. And so you can't use solder. We found that you cannot use solder with a copper pipe there, because solder, is fairly soft. If that antenna swings back and forth. Yeah. Oh, somebody say something? I think it was Ken's mic. Anyway, well, this rocks back and forth all winter long. And that's just solder holding it. It won't hold. It'll come right off. You have to weld. Maybe on your own personal roof will hold, but not up on a repeater side. We've tried this. It will not hold. Falls apart. So this is not a very good design in terms of holding up. I mean, if you can feed it just right, it'll work. I think performance-wise, it's not a problem, but just physically. So antenna design really it's got to work electromagnetically, and it's got to hold up physically. So that's why I approached the Ribbon J. I mean, I was really intrigued by it. I got first introduced to it back in the 1990s. Denny Monticelli, AE6C, said, hey, Ed, check this out, the antenna. And they made it out of twin lead, Radio Shack twin lead. And I brought it home and I said, that actually works pretty well. I could tell from my backyard that it's better than my ground plane. And it turns out it's about 1.5 dBs better. Not significantly better, but you could see that it was better. Now the disadvantage of a J-pole, and I think I'll show you this. The disadvantage of a J-pole, I'll get into this detail later. You got a half wave. See, in a normal dipole, you would have fed it in the middle. But in a J-pole, we'll get into this in a while. But the height is 3 times taller than a quarter wave. So there's a half wave here, and there's a quarter wave matching stuff. So it's really, we can look at it as 3 1/4 wave pieces. It's taller. It definitely is taller. But it works well. And again, if it's just vertical force, you can tolerate that quite well. So let's get back here. So I liked it, although it was now not 19 or 18 inches for 2 meters. It was more like 36 plus about 50 inches, a little under 50 inches. But that was okay. And it worked. And I said, you know what you got to do? It's so cool. It was a roll up in a ribbon J. I said, we got to stick this thing in a PVC pipe and make it into a base station. Because that idea is pretty cool. And so I did, and you have to readjust for it. You put it into the PVC pipe. The pipe has got a velocity factor. So people ask, what's velocity factor? And I think a lot of you probably understand it. But I actually didn't understand it that well 30 years ago. I said, it lowers the resonant frequency. What is it exactly doing? This is what it's exactly doing. When you make an antenna, let's say 146 megahertz out of ribbon cable or something, and you stick it into a PVC pipe, that half wave, 18 inches for a quarter wave, so double 36 inches, that's in air. Where does that 36 inches come from? It comes from the speed of light is equal to frequency times the wavelength. If you don't remember it, you had it on your exam. You had it on your ham exam usually. So always that formula, the speed of light c is equal to frequency times wavelength. Well, the thing is, when you stick it in a PVC pipe, you cannot use about 3 times 10 to the 8th meters a second for the speed of light. That's in air. If you stick it in a pipe, it slows it down by 5% or so. So what it's going to do is immediately, if you did a resonant ribbon J, resonating or hanging it, it's exact 146 megahertz. Now I don't want to leave it out because it won't hold out. I want to stick it into a PVC pipe because it's nice and rugged. You will find that the frequency would drop about 2 to 3 megahertz depending on the thickness of the pipe, because you still have to obey C equals F lambda. You can no longer use C. You're no longer in air. You're going to go through the pipe, and just think, when it goes through the pipe, does it speed up the speed of light or does it slow it down? Well, nothing speeds up the speed of light. It must slow it down. It slows it down by 5% or so. So you have to readjust. So you always have to readjust. It doesn't necessarily degrade the performance of the antenna. People say, well, does it get lossy? It can if the PVC pipe had what's called a loss tangent. The loss tangent is another parameter. It's not the velocity factor. It's how much heat does it absorb. Well, fortunately, the pipe we use, as far as we know, it's the lowest around. And John Fortune confirmed that. I don't know if you guys know John Fortune, W6NBC. He writes a lot of articles, really nice guy, very well known. Yeah, he actually did a whole experiment on different pipes. And we didn't do the experiment. I did a crude experiment. We found that the Lowell's 23990, it was, he used measurement equipment and all. I was just basically a spectrum analyzer sticking it in. Hey, it looks good. I don't see any difference in attenuation by sticking it in the pipe, PVC pipe. But of course, when you stick it in the pipe, it's protected, right? That PVC pipe is pretty rugged stuff, UV protected, and it's very hard to destroy. But it does slow down that wave. And then C equals F lambda. You can't use 3 times 10 to the 8th meters a second. You got to use like 7.7 to be realistic. Then it turns out the F is the same. C is equal to F lambda. But the wavelength of, let's say, 2 meters inside the pipe won't be 18 inches. It'll be like 17 inches, 17 and a half inches. You have to trim it. Then it'll work fine. It will work fine. And we found that the PVC pipe, this stuff they tell you will last 30 years. I've had mine up for 20 years. They're right. It does not deteriorate. This is not the old. I remember growing up, I don't want to use PVC pipe. The thing turns yellow and cracks. Not this new stuff. New stuff, you can't figure out how to get rid of it. In fact, I think our scientists are working on how do you get rid of these plastics that 3M and some of these people have developed. They wanted a durable plastic like Lexan, great. It's so durable you can't get rid of it. But that's the problem they have now. It won't degrade. Okay, so we've got to date antennas like this. We've shipped actually well over 40,000 now in the last 20 years in my group here. So I'm sure a lot of you folks have tried these and they work, but how do you make a dual band? And I have another talk that makes a tri-band. How do you make a dual band? Well, it's just like, I published this in 2003, so early 2000s, we were developing this. I go to these swap meets and everyone's going, hey, everyone's buying these 2-meter or dual band handy talk, these dual band mobiles. Icom was coming out with them 20 years ago, Kenwood, Yaesu. And you could buy a dual band antenna, $200. So, hams, I'm sure hams up there are no different than hams down here, right? We're engineers. We like to say, well, if we don't have to spend $200, we won't. So people start asking, is there any way you can make my single band antenna dual band? Because I bought a dual band radio. Now, well, you can't make a dual band radio. That's pretty elaborate, but maybe a dual band antenna is realistic. So I said, let me take a look at this. Because people, what they notice is that J-pole they made for 2-meter out of copper piping. This one's pretty popular here. Actually, have one here. This one became pretty popular, right? The copper J. I think it appeared in QST. But they're single band. Except that when a lot of folks put their little bird watt meter on it, they go, hey, it kind of works. The SWR's not bad. Below 1.5 to 1. And then they start using it. The good news is if it's below 1.5 to 1, your radio's not going to blow up. The next thing doesn't work. Well, that was kind of disappointing. When you quantify it, really a 2-meter antenna used at UHF at its third harmonic, unmodified, gives you about 6 to 8 dB of loss. In fact, let's see. I think here. You do an easy neck simulation. Which is free these days. Here it is. This is in free space. In free space, it's just, even though we can't build an antenna in free space, it's good to compare everything else, right? Reference free space. So in free space, it will look like this. Vertical quarter wave antenna. And in the fundamental, which in this case is 2 meters, you look at the side. And this is the sky, this is the earth, and this is sea level right here. And you look through the side, and it looks like the figure 8, the familiar pattern figure 8. So, the way you would test is you stand here and your friend starts walking out here and you see how far you go. Well, and the pattern in free space, on Earth, it wouldn't be this way because you have buildings, but let's just compare. It looks like this. Shift everything up to UHF, the third harmonic. The third harmonic will still give you a reasonable SWR. And you can explain that pretty easily with the Smith chart, but aside from that, it will still give you a decent SWR, but the pattern is quite a bit different. The pattern is what's called a 4-leaf clover pattern. And I'll explain this later, just intuitively why you get this. But what you're interested in is, I'm setting at sea level. I'm sitting right here, and my friend and my partner's walking on, we're seeing how far we go until we lose a signal. Well, if you can operate the antenna at your third harmonic, unfortunately, 75% of your signal is going into the sky at 45 degrees, and only about 25% of it's left. So what you would experience is all of a sudden your nice 4-watt, you thought your 4-watt Baofeng radio you picked up for $20 is going to work, and you use this fundamental 2-meter antenna on 440. You might as well use a 1-watt radio. That's how it will perform. It will perform like a 1-watt radio using a quarter wave antenna. And if you use a J-pole at 2 meters using UHF, you lose 75% of it. The pattern would be in free space. About 75% of it would just go up into the sky. And what you're left with is 25% of it on Earth. So not a very good antenna. So a lot of people, they notice this pretty quickly. Yeah, that SWR is good, but boy, you can really notice it does not work. So they said, you think you're a smart guy? These friends of mine, I said, you think you're smart, right? I don't know. just do whatever I'm telling, I have fun with life. I run a lot of ham clubs, and I don't know if I'm smart, but and we just run, I don't know if you guys are from down here, I run the flea market down here. We have a flea market, big flea market every month. That's how our club raises funds. That's why we got dues. Anyway, they said, hey, here's our problem. Can you fix it? I said, well, that's an interesting problem. So I started looking at it. I go, well, with hams, you have a few rules. It's got to be fairly simple. It's got to be, if it's going to become popular, it's got to be reproducible. Like publishing QST. So that actually puts a lot of restrictions. Can I add the second band on this antenna? Basically, to make it look, I want VHF and UHF both to take on this pattern, not the UHF losing 75% of the energy. Obviously there are expensive ways to do anything. You pay enough money, just go buy your own antenna. But it's simple, reproducible, and cheap. It still have the functions like no radials, and still basically keeps the J-pole design. I worked on this. And yeah, no external inductors you got to buy. Inductors at UHF, there's no good inductors at UHF. You put them on a network analyzer. They've got series resistance. They have self-resonances because of its parasitics. Capacitors are terrible at low Q. So you can't use any of this stuff. I'm sure you can buy good capacitors, but they're not cheap, and you have to really search them out. And you can't require that on a QST article. Oh, go buy this weird capacitor we need to resonate and cost you, $10. You can't have that. So it had to be simple, reliable, cheap, and they can do it. So I tried all types of things. I worked on this on and off for like 6 months, on and off at night. I was just wondering, but boy, I could save a lot of people a lot of money. So at night, I tried this. I tried a lot of things. It had to be reasonable. So this is what I came up with. Okay, the first thing you got to know, a Smith chart. You don't have to know everything about a Smith chart, but the only thing you have to know to understand our design here with the dual band is that a Smith chart says this. If you short circuit a transmission line, like RG174, RG8X, whatever. If you short circuit it and you go a quarter wave, it will be an open circuit. Now, you RF guys, yeah, we know this, but actually most hams, you think in terms of DC, most hams do not know this. And if an open circuit, well, let me just get you a quarter wave stub to show you this. I've got a bunch of quarter wave stubs here. Okay, hang on. Yes. Here we go. Okay, here's a quarter wave stub. I'll show it to you. Quarter wave stub, that's about 5 inches. RG58. And I say, hey, I know to new grad students, I say, well, it's an open circuit here, right? It's not shorted, no tricks. What is it here? I would say all of them it's an open circuit. And I tell them, yes and no. It's an open circuit at DC. We think of everything in terms of DC intuitively. That's why AC is so much more difficult. Signals and systems. It's a different way of thinking. And the way I try to turn around my graduates since the first year ones, I said, put it this way. If I gave you here, a piece of paper, is that an insulator or is that a conductor? And they'll say, oh, it's an insulator. I go, it is at DC. But when I say AC, what is AC? ACs are radio signals. Radio signal, I don't have to convince you. We'll go right through this, right? Or your house that's built of wood, let's say, built of wood. You still get radio stations on your radio because wood, most things that are insulators at DC are conductors at AC. That is when you have a signal, the conductors. And the opposite is also true. I'll show, a drink with a aluminum can. Aluminum can. Is that a conductor or is that an insulator? Well, they'll say it's an insulator. It's a conductor. Yeah, of course it's a conductor, aluminum. But for a signal, if I were to put a little handy-talkie receiver inside the can, it will shield all the signals. That means that aluminum can is a Faraday shield. an insulator for RF. So it's almost a direct opposite. So that's why you have to remember, the Smith chart says, if it's infinity, an open circuit, and you go a quarter wave, in this case, a quarter wave for UHF is about 5 inches. 5 inches, it will read a short circuit. And if you go a short circuit and go a quarter wave, it would be an open circuit. That's really important. I mean, if you guys are experienced hams, you use this all the time. It's really, really, really handy to understand this. Okay, so let's go back here. So how does a J-pole, but just start out with a standard J-pole. How does a standard J-pole work? It's some clever, I think ZEP, like you just call it a ZEP antenna to invent this. This is what it does. Here's a halfway, in this case, it's twin lead. You don't need this piece here. That's just a twin lead with the notch, the cutaway. So that this is the half wave. 37, 38 inches in that range. That dipole we saw earlier, this one. Here's the same 37, 38 inches. Could you feed it in the middle? Yeah, you could, because it's 65 to 70 ohms. You can feed it with coax ohms, it's 90 degrees, because otherwise you'll interfere with it. 90 degrees, and it's farther away, the better. That's not very practical, but yes, the better. So yes, this will work, but it's not practical from a physical point of view. But let's go back to this now. So we do have this half wave. We say we can't feed it in the middle. It's pretty dangerous to feed it in the middle, because then you'll need a big arm to hold it off. And, electrically, it's okay, or electromagnetic, but physically, it is not okay. So we would love to feed it at the bottom. As I demonstrated, if it's just vertical force, you can hold that forever, the effort. We would like to feed it at the bottom. But the bottom, or the tips, the ends of a half-wave dipole is not low impedance. It's high impedance. That's how antennas work. It's a high impedance, and it radiates into air. That's why when you touch that, right, when you have high power, you get RF burns at the ends. The high voltage is at the end because it's a low, high impedance point. If you touch it here, you wouldn't get a burn because it's a low impedance point. High current, but low voltage. Here it's high voltage, low current. So this is a high impedance point. How high? If you measure it on a network analyzer, in the thousands of ohms. That's high for RF. Thousands of ohms. So how are you going to match that? How are you going to match that? So here's basically a J-pole without all the math. I said, if you short circuit a piece of coax like this, or transmission line, short circuit it. You go back to the Smith chart here. You short circuit it. If you go a quarter wave on that transmission line, and what's a quarter wave at VHF 2 meters? It's about 18 inches. 18, 19 inches. Now, that's an air. In twin lead, because again, it has a velocity factor, it slows down the speed of light. That 18 inches came from C equals F lambda when you enter C as the speed of light in air. The speed of light in that transmission line is not 3 times 10 to the 8th meters a second. It's about 3.5 or something. I mean, 2.5 or so. Where that quarter wave, instead of 18 inches, it's only 15 and a quarter plus 1 and a quarter, 16 and a half. 16 and a half inches. So it shrinks a little bit because that signal, that VHF signal going through here is not traveling at 3 times 10 to the 8th meters a second, about 2.5, 2.6. Slows it down. So you have to adjust accordingly. But you can. Once you adjust accordingly, it's fine. And now, I said, well, this is a short circuit here. Short circuit DC, right? DC, 0 ohms at DC. Now, that means we're starting here, short circuit. You go around a quarter wavelength. You have realistically probably not infinity, but very high impedance. Right? In reality, there's no such thing as a pure short and a pure open, right? Close enough. High impedance. So you start out with a short circuit, go up a quarter wave, and you figure high impedance, but the end of this antenna, the half wave dipole is also high impedance. So you've matched it to that point. You've matched it. If you're going to look at it from a voltage point of view, obviously a short circuit is 0 volts. And as you go up a quarter wave, the voltage peaks. That's also the peak of the end of the dipole. That's another the same. It's matched. Fairly well matched. So the energy will transfer to that half wave dipole. And then you say, well, I need a 50 ohm tap. common sense says, I don't need any math for this. If this is a short circuit and this is, ideally infinity in the Smith chart, it's probably in reality, a couple of thousand ohms at least, a couple of thousand ohms. If that's 0 and that's a couple of thousand, you just empirically find where 50 ohms is. How do you find it? With network analyzer, right? Keep on moving up and find the lowest SWR point. I mean, that's how I did it. You don't need math, don't need heavy antenna analysis. And it turns out to be 1.25 inch in that range. And you guys that have these antennas, either you built J poles or have mine, it's reasonable. Is it perfect? It doesn't have to be perfect. 1.1, 1.2, that's good enough. So that's how a 2-meter one works. But how does let me show you. So a lot of ways of implementing this, right? Copper J, right? Again, I wouldn't make it like this anymore today. Copper is just way too expensive. It'll cost you a fortune. But yeah, here's the half wave part. Here's the quarter wave part. Here we have it blown up. Here's the DC short, right? It's the short circuit. You go up a couple of inches, whatever it is. You tap it over, and that's the 50 ohm point, because that's the high impedance point. That's 0 ohms. So 50 ohms got to be somewhere in between, right? Now, the question is, how well does this work at UHF? This is the dimensions for VHF. So what happens at UHF? What happens at UHF is this. Actually, I'll show you this on the slide here. What happens at UHF? Why does the thing match at UHF? The reason why it still matches, you have to look at the Smith chart again. Remember, I said, if this is 0 ohms and I go a quarter wave, it's infinity or very high impedance. If I go another quarter wave, it's back to 0. And I go another quarter wave, it's back to infinity. So what does that say? At UHF, the waves look like this. You start out with a short circuit. Now VHF is a quarter wave. So here it is. That's a quarter wave. Smith chart quarter wave hits a peak, high impedance, high voltage. At UHF, it still starts out with a short. But if you go up a quarter wave, about 5 inches in this case, 5 inches, it'll reach a peak voltage. But it isn't done yet. Now you go another halfway around the Smith chart. It's back down here. And that's about 10 inches. And then you go another 5 and half inches or so. It reaches back a peak, which means it's also high impedance. So that's why an antenna at VHF will have a reasonable SWR at UHF. It's just 3 1/4 waves up, because you've gone to another half wave around the Smith chart. You're kind of back where you started from, and then you go another quarter wave. So, but of course, the voltage distribution is a little bit different, but in the end, it winds up the same. You're at a high peak voltage. Actually, it's out of phase. It doesn't matter. It's out of phase. But you're at a high voltage, which is high impedance. It'll match into the antenna. That's the reason why you put a SWR meter on this standard J pole. SWR looks good at UHF. That's because it went another half wave. But what happens? What is really happening here? What is in your J pole, the 2-meter J pole that I said, wow, this SWR is okay at UHF. Can I use it? You can, but let me tell you again, it loses about 6 dB. The reason why is you would like to see that let's go back here. At UHF, half wave is about 11 to 12 inches, depending on what frequency you're at. Actually, it calculates about 11.25 if you had 445. It would like to see that half wave, which is 11 to 12 inches at UHF. And if you did just see that, it will work fine. But then, of course, it won't work for 2 meters, right? Because at 2 meters wants to see 37, 38 inches. So that's why when you had the original J pole here, 37 inches. This is for VHF. For UHF, right, it went around a half wave and it peaked again. And now it's sitting here and says, wow, impedance looks good. I'm going to march ahead. It marches ahead, but it wants to see about 11 to 12 inches to peak the voltage. That's the half wave. But you notice it sees 37 inches. It uses up 12 inches. I got 23 inches left. What am I going to do with it? It doesn't know what to do with it. Instead, the current continues, and it continues out of phase, wrong phase. That's where you get the cancellation. So the energy doesn't go nowhere. It has the wrong phase and it pops up into the sky. It's just going to where you don't want it to go. So as far as you're concerned, it's lost, right? I mean, unless you're flying an airplane or the space shuttle or International Space Station, as far as you're concerned, you just warm some clouds and it's gone. So you don't want to do that. So what you want to do is, again, come back down here. You want to stop it at about 11¼ inches. So let me go back real quick on these antennas. So that's the implementation of a copper J. And by the way, this is the one that works so at UHF. It turns out that and we looked into this. Why doesn't this work at UHF worse than 6 dBs? It's because this transmission line that you made is good at VHF because you're making it out of pipe, and you're at UHF you would like it to be a lot more narrow, at least a quarter of that spacing. But you're not allowed that because of the T and the elbows. This is the best you can do. It turns out that's not a real good transmission line at UHF. But at VHF, it's still acceptable. VHF quarter waves, 18 inches. That's about 1½ inches. Hokey transmission line, but it turns out that we build them right here in our lab for experimenting. It's actually okay. A lot of people say ours works better because we're using rotwin lead at only 1/4 inch. Of course, that's a better transmission line at VHF and UHF. But we have one. I would say it works better than nothing. But it does not do UHF for sure. But whatever UHF it does, it's just some spurious radiating. Here you've got almost 2 inches at UHF. UHF is about 5-6 inches for quarter wave. So just a hop across here, it's already radiating, and it's already radiating in a horizontal direction, wrong polarity, right? So it's kind of a lost cause at that point for UHF. So actually, Arrow came up with a good idea. They knew that problem, so they had the standard J like this. And they said, well, we need to put UHF in here. So they added an extra piece. So at UHF, actually, they use this piece here. Here's the J at UHF. And then at VHF, they use this part here and this long 57½ inch piece. So here's the UHF antenna. And then here's here's the VHF antenna. And then here's the UHF antenna. That was a curious design, so obviously we bought one. I have it right here. We've experimented with it. Right here, we can take measurements and all that, and you gotta hand it to them. I don't know if they patented it or not. It's probably worth a patent. It's an improvement, but again, what happens is they have one feed point here, and what happens is when you feed a UHF signal, that VHF antenna is still in line. Now the good part is, and let's say they're equally matched. That means it's like having 2 parallel antennas. Here's the UHF antenna in parallel with the VHF antenna. And let's say they're equally matched, so half the power goes to the proper antenna at UHF, half the power goes to the improper one. So without all the math, quick explanation is, in this antenna, the arrow, half the UHF power is correct, but you can't prevent the other half from going into the VHF antenna, of which you just lose about 75% of the power going that radiates in the sky. So it's an improvement, but still you're losing some signal. And a quick one, whenever you hear the term Slim Jim, that's just a standard J-pole. That don't buy any of this stuff. It gives 6 dB a gain. No, there's no validity to that. It's just a standard J-pole, single band. So anyway, go back to this now. So I hope I've convinced you that at VHF, this is the quarter wave. At UHF, it's 3 1/4 waves, and it'll be still matched. But what I would like to do is go up 12 inches, 11, 12 inches, or halfway, stop it, electrically stop it. If I could physically stop it, it'll work, but then it won't work at VHF. I just want to electrically block it at UHF, only for UHF signal. So we just use a quarter wave stop. Remember, I love these things. Quarter wave short isn't open. So it turns out to be a 4 1/4 inches. You would think it's like 5 or 6. No, because RG174 has a very high velocity factor. In other words, it slows down the speed of light by quite a bit, by 25–30%. So it actually turns out to be about 4 1/4 inches, not 5 or 6. That would be an error. That's a short, so that's an open. But it's only an open at UHF, at the resonance. At VHF, no, it's not resonating. It goes right through. So at VHF, it sees 11 and a quarter, 4 and a quarter, and 17, which is, I think, we added up to 37, 38 inches. So that's how it works. I'll stop there. Any questions at this point? Is everyone lost, or see, so far I haven't had any equations, so. Wave of hands or on the audience. Basically, does this make sense?
Yes, it's very, very clever.
Yeah, it's intuitive, right? Without the math. I mean, you can figure out all the math and everything, but you know, I'm a true. Thanks, Joseph. I'm a true engineer in that I tend to do things intuitively first. It's got to make sense. Like, does this approach make sense? Sure, as an engineer, you got to work out all the details. You got to build the thing and figure out exactly what the dimensions are. That's the engineering, all the math and the simulations and all that. But it's got to intuitively make sense. That's what I teach my students. I think good engineers are more artists initially. The good thing about an engineer is you start out as an artist to be creative, but you know how to work out the details. How do you actually get the thing to work based on those principles? So here's the principles. And yeah, does it take quite a bit of effort to get it all working right? It does. I mean, I showed to some of my students, say, hey, this is actually pretty hard to get going, isn't it? That's why we special order all our twin lead, our coax, we go to the same manufacturer. Why? Because they have different velocity factors. The material densities change. You know, you just can't afford to be manufacturing antennas with 1/4 inch here and 1/8 inch there with every different lot of wires. So we just ordered all from Seminole Wiring through HROs. And we ordered tens of thousands of feet of this stuff. Okay, any questions at this point? So anyway, I'll take questions at the end too. So here's the roll-up version. The roll-up version is just that one of my students said, "You made a roll-up, I like the backpack." I go, "So do I." So it's the same principle behind it, except we tried to get an all one twin lead, and we had heat shrinks and supporting it. And it's pretty cool. We experimented with it a lot to get it to work. But what's interesting again is if you take the roll-up version as opposed to the one that goes into a PVC pipe, you add up these dimensions. 15 and a quarter, 1 and a quarter, 11 and a quarter, 4 or 17. Now, take the roll-up version. Now it's 18 here. This one still stays about the same. This one actually is a little bit longer probably, and definitely longer here in the matching, 16 as opposed to 15. It's about 2 inches longer. Why is it 2 inches long? It's not in the PVC pipe. When you calculate this antenna, for C equals F lambda, for C you use the speed of light, 3 times 10 to the 8th meters a second. This one, you have to use about 2.8 for C. So the dimensions are slightly different. Some people ask, well, what happens when you plug this into a PVC pipe? Of course, I've done that. Let's say you tune it to 146, it'll resonate at about 142, 143. Off enough where you can't ignore it. You cannot ignore it. Okay. Let's see. Okay, so here's spectrum analyzer measurements. Spectrum analyzer measurement, yeah, it does work. Here we have a 2-meter J-pole at UHF. This is just a reference. In a parking lot, it's a Sunday, so no cars. Spectrum NHP or Keysight spectrum analyzer. We tried to keep everything constant except for the antenna. So we just took a reference. 2 meters J-pole used at UHF. All of a sudden we use our J-pole with that little stub. Sure enough, 6 dB comes right back. And that's a lot, that's 4 times. That's like your 1 watt HT here. Or let's rephrase it, your 4 watt HT. Your 4 watt Baofeng looks like this on a 2 meter antenna used at UHF. But if you use our technique, you get about 6 dB of gain. That's 4x. 4x. So 1 watt looks like 5 watts or 4 watts. So it's significant. Putting that little stub there really does make a difference. And then I had one of my students do a bunch of measurements. We had to confirm the measurements in what I was trying to teach them how you get approval from National Institute of Standards. And we read it. It's quite elaborate, to tell them you got gain. You just can't make one measurement. You got to make a bunch of them. Foggy days, overcast days, rainy days, and sunny days. And we took 5 measurements of each, took the average, and sure enough, you get about 6 dB of gain. Here at this is just a VHF, measured relative performance of dual band at VHF. Here's a quarter wave reference, minus 24.7. Rubber duck, as you guys know, is terrible. You lose about 6 dBs, you really do. We took 15 measurements like that, and you on average, you lose 6 dB. The standard J-pole, it is better than a ground plane. Not by much, by about exactly like what say about 1.5 dBs on average. Is it significant? Not significant, but every little bit counts. 1.5 dBs. You wouldn't want to lose it. And if you use our dual band J-pole compared to the standard VHF J-pole, again, we took 15 measurements, and our little stub, you do lose about 0.1 dB is what we concluded. There's a little bit of loss at VHF. Why? Because look at it. There. At VHF, it goes through here. It would love to just see one pure wire. 36, 37 inches long. Yeah, but it runs into this little stub here. And you have to have that, right? You have to have that for the UHF decoupling. But unfortunately at VHF, it's going through here. It's not resonant, but it's going through here and it forms kind of like a capacitor with this before it sees back to 17 inches. So and apparently that loses about 0.1 dB. Not perfect, but that's pretty small actually, but it does lose it. Oh, okay. So at UHF, a reference is minus 38.8 dB. At UHF, a rubber duck isn't so bad. It loses 2 to 3 dBs. In fact, if you're really careful with a good HT, one of these big ones, which you probably don't have anymore, with a good metal chassis, you lose very little. But use like a little Baofeng, right? It's just not enough metal to make up for that extra quarter wave. Yeah, still lose a few dBs, but not like 6 dBs at VHF. At VHF, a rubber duck really, really hurts you. You guys probably know this. I don't have to tell you this, right? Use a rubber duck and it's lousy. But now use a standard J-pole at VHF. A VHF J-pole at UHF. Oh, not good. See, quarter wave reference is minus 38.8. You do lose 5 or 6 dBs. So that's why, yes, you can use a VHF antenna at UHF. It won't blow up your radio. The matching's okay, but the performance is just really, really lousy. Add that little stub, boom. Instead of minus 45, now you're only at minus 38.9, about 5, 6, not quite 6, 5, yeah, 6 dB, 6.1 dB. That's a lot, about 4x. So, and I think I confirmed this, but I think the ARRL confirmed it too. And a lot of people have tried this and it does work. Simple. I mean, in principle, it's simple, but try to get the right dimensions and everything. If you guys want to ever build one, give me a call. Step by step, how you know you're in the right track. Because it is hard to get everything resonant. I covered it in our article, but you got to read it really carefully. Okay. And after you build this and you think it's challenging, how do you add a third band, 220? So think about what I was up against. But on our tri-band antenna, I can give you a talk on that if you guys like. I had a good incentive. FEMA said, if you can get us 2 meters, 220 and 440, all in one stick, no radios, no lightning arrestor, because they were using the CX333. That's a $200 antenna with radios. So they needed a lightning arrestor. And I said, well, if I can get something like this going, how many would you buy? And they said, we'll buy thousands from you, thousands. We'll replace all our antennas. Well, that's a good incentive. Like what I tell my wife, well, she goes, why do you do this stuff, Ed? It's interesting, number one, but I'm a pretty practical guy. It's the ka-ching part, right? Ka-ching, 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 money. And yeah, they've bought, I haven't kept track. They've bought thousands from us, thousands, and they love it because they use 2 meters, 220 and 440 in their emergency bands. They don't want to be carrying a bunch of antennas. They don't want to be putting radios. They just need communications and quick, right? They're into disaster recovery. And communications is one of the things they have to have, and reliably. And so, yeah, when they said, if you build us this, this is the antenna we will accept in our FEMA system. They buy it. I don't know if it's totally accepted, but they certainly buy a lot from us, a lot. So it was worth it. So anyway, so that's how that works. Here's our lab. Here's our lab back in 2008. See, we used to use an 8753. Still have that. It's a really cool unit. No microprocessor needs. Brute force network analyzer. Keysight. Well, they called it HP then. $85,000 works fine. Still works. Their newer one is their 5062, but I don't even use that often. I use this little tiny thing, which most of you guys have, right? The little nano VNA, man. It's actually really, really good. Really good. I require it like a textbook in my classes. You buy a textbook, you need a nano first. We'll give homework assignments on this thing. This is a really actually I'm trying to show the audience. I'm trying to get the video where you show them. I want to raise your hands. I don't have that slide. How many of you guys have one of these nanos? I'm sure you should. If you don't have one, you got to get 95 bucks. It's a steal. Worth more than a textbook. So you see me hold one right here. Very handy to have. Let's see. So that's what we use. Oh, here's one before I end. So people say this, the stub. How good is a stub? Yeah, it's not infinity, right? It's a short, that little quarter wave stub, but it's really high. You know, if you had like a cavity for a repeater, it will start sitting here. A little RG17 where it sits high, it works. Again, you get that little bit of loss, but you get a lot of gain. You get 6 dB of gain. The stub itself probably does have some loss because it's not infinity. If it were ideal, it would be infinity, but that would require like a cavity. Let's see. Oh, I see. And it's pretty stable, or sitting here. I put my hand around and everything. At resonance 445, it's pretty stable. It's definitely doing its job. And again, if you want a lower loss, make it out of RG8X. You can even make it out of LMR 400, but then it gets really bulky. And it probably won't be that much of a difference. Oh, that's a wire. A wire is open circuit like this. Let's see, here it is in my house. Again, it's all vertical force. It doesn't take much vertical force. If that thing were laying at 45 degrees, it'll be a lot harder to hold up. Okay, and here's the roll-up we offer. Here's the antenna. We have it in a BNC male, and then we include the adapters. So you go to SMA male or SMA female to convert that. We also include, we make these custom. Basically, you need a extension cable people can buy. Custom make it out of a BNC male, female. So you just plug this in here and you get 6 feet, or you want another 6 feet, just add another one in. So that is how we raise money for my RF wireless group. We don't have any grants anymore. Oh, so here's some other talks I give. If you like this one, hey, I don't know how you guys are, but I am unfortunately one of the guys responsible for getting talks for our club every month. And you know, after a while, you just use up all your friends, use up all your network. I've been doing this for 30, 40 years. So if you need a talk, here's another talk. How do you get gain out of a collinear? It isn't making a Slim Jim. It's pretty complex in terms of how to get gain. And I've made these things up to 4 elements where they've used them on repeaters. I use it on my repeater. And you know, I have to say, actually, if you do it right, it works pretty well. I mean, I did this with 4 elements, a collinear. And you know, we have site master antennas and cell wave antennas. I have to honestly say, I can't say theirs works any better than ours. They both work pretty well. And again, you know, I hand tune them, and I have to say, put it in a PVC pipe. It's all protected. Performance is, I think, equal to, you know, the commercial ones. Of course, the commercial ones use similar designs like this too, also. So, well, then here's the tri-band one. How you add 220 coils into the already existing dual band and get it to work right. So I give a little talk on that. Let's see what else. Oh, I don't sell these. These are just cool radios. I think we give these as prizes. If 2 meters, 220, 440, you know, for 100 bucks, I think they're even dropping in price. Even the B-Tech tri-band is like 30 bucks now. You know, if you guys are into 220, I mean, I do 220 only because we've got every repeater slot is taken up here on 220, but nobody ever uses it. Never hear anyone except Condor. Hey, you guys get Condor where you're at? Are you you have a Condor node? Anyone answer that?
Yeah, can you hear us?
Ken,
Yeah,
you guys get Condor up there? The Condor from San Diego, I know, all the way to Oregon. The 220 network.
yeah. Can you hear us?
Yeah, I can hear you.
Oh, okay. Yeah, I don't know that we do get Condor up here. Does anyone know?
I don't think so then. Oh, you guys get wind systems, right? You have a wind systems node?
No,
You don't?
but when link,
A wind there. Oh, no, but wind systems where it's a repeater into the system. The wind systems is, they've got nodes in Hawaii, Alaska, Arizona, Texas.
Yeah, we don't get that
You don't?
that system
Oh,
here.
man.
No.
You're
Yeah.
missing a lot. Oh, they got
But-
the,
Sometimes it's on the 440.4 machine.
oh, they'll link it or something?
Hmm.
They got the Insomnia net at, are you saying 11 o'clock or 10
Right,
o'clock?
they do have the Insomniac net.
Yeah, you hear that?
Oh, you do? Okay. Yeah, is it in Portland? The 440?
Yeah, the W7RAT, I think, is the call.
Oh, okay, okay. Yeah, I kind of listen to that. Just it's interesting. You learn a lot about winter in Alaska. Those guys really look forward to 10 o'clock when there's nothing else to do up there in the winter.
we know all there is to know. It's cold.
Yeah, 12, you see all these guys. Oh, how are you guys doing? It's like the biggest thing of the day is 10 o'clock wind systems net. And it's like, wow, if that's your biggest thing in your day, you need to get a life. But I guess in Alaska, there's not much you can do. So I know there's a guy in Japan that checks in every now and then. There's a guy in Israel checks in every now and then. And then I don't know, is DMR big where you guys are at?
Yeah, there's some activity on DMR.
Yeah, I hear all kinds of guys at DMR. That's kind of fun, of course. I like, here's my favorite radio. Are you guys familiar with this radio?
I'm not.
That's cool. That is a cool little radio for $155. It's a full HF SDR. Got a built-in 4 ampere-hour battery. It's originally started with the California QRP club, and it's done in an FPGA. It's really cool for 155. All mode, all band, even has a built-in CW decoder. Of course, a built-in keyer. I take this camping. Wherever I go, I could set up an antenna so quick. I take it on a cruise. The battery's built in. You just need a mic and then a charger if you want. And then I have trap dipoles that I set up real quick. I like dipoles because they work really well. Some of these portable antennas, they resonate, but they don't work real well unless you're in a real good location. Well, I think we give away these raffle prizes that are amazing. People love this one. It's got a USDX Plus. The originally started by the Northern California QRP Club, but they built on this, and guys have added to software, and I had nothing to do with it. I just play with it. I think it's cool.
Where are they being built, Ed?
A lot of people, a lot of folks, if you need one, give me a call. The thing is, they're being built in China for the low price, manufactured in China, the boards and everything. But I tell you, if you want one, contact me. I can get a hold of them because we've narrowed down the good manufacturers.
Oh, all right.
They all look the same, but right, because they're taking how the QRP Club is. They make the board and software public information.
Yes.
So they just take it. These Chinese, they want to make money too, right? And they'll put it together. And we have figured out which vendors. Not all the vendors are the same.
All right. Well, maybe I'll find out and we'll post it on our website.
Yeah. If you guys need one, our club buys a bunch of them because Ron knows exactly who to get them from. And good price. And the prices are with the battery and charger and everything, with shipping and tax, it's about $155. But I don't actually know the vendor, but he gets them for us, and yeah, they all work, and they work really well because he's gotten some that at flaws and stuff like that. So if you
Is that
need
a 5-watt radio?
yeah, 5 watt, it's really cool. I've got a kilowatt obviously at home with the 30L1, and I worked DXCC years ago, but now I have lots of fun with 5 watts. How many people can you work with 5 watts? And the bands are pretty wide open these days. So, but the advantage of this, I can go up way up in the hills. There's a reservoir by my house. I can get it to a good location at 5 watts, and it really, I work a lot of POTA folks on the weekends. It's I don't know, it's lots of fun. We have California QSO party coming up in October, and I'm renting a cabin up in the Santa Cruz Mountains here. And we have lots of fun. And I just bring this radio. $155, even if you lose it, what the hell? Let's go buy a new one. But handling a lot of new stuff that's still lots of fun. Here's the insides of it. It's got a little speaker. This is really well. I mean, they've worked on this stuff for years, right? California QRP. They started with the mainly it's a little radios with low power, but they've added. It used to be just CW only, and they got really sharp engineers working there. Wayne Burdick and these guys, right? They really, and so it's got all the resonators of the different bands, and it's based on the synthesizer is based on the Silicon Labs chip, and then later the basic radio is based on, I think, is it this chip? No, this chip. No, this chip is a Atmel 32,000 microcontroller chip. It's an SDR. Yeah, I mean, it's really cool. Uses BS150 FETs. They're 50 cents each, and they're right here. And it's a switching RF amp, so it doesn't even require a heatsink. Puts out about 5 watts. That's pretty cool. I mean, these guys have done a really good job. I mean, I couldn't do it myself. I just like to appreciate what they've done. And even the speaker, we tried different speakers in our club, because we're really into this radio because we think it's amazing. They even tried all kinds of speakers. The one they have is the best. This one, it's got a little baffle in it. It's really small and it sounds okay. You know, if you guys are interested, don't try all these vendors. I know Ron KI6AZB has tried a bunch of them, and he knows which are the good vendors. And that's it. Okay, so I give these talks. If you're interested in these antennas, that's how I fundraise for my RF group. The one I just talked about is $38. That's 20% off what we normally sell them for off our website. So you get a really good deal, 20% off. And we make them either in ham band, like what I talked about, or commercial, MERS, GMRS. So it's 2 different antennas. You got the ham band one or the commercial one. You can't get one to cover everything. The Q's too high. They'll make the roll up, same thing. Then the tri-band one, I have not given you a talk on it yet, but I could in the future on how that works. That's $65. Let's see. And then a lot of people are interested in GMRS now. That's the gain one. I also make that gain one for UHF repeaters. But I would say that the gain one, primarily people buy for GMRS. It's about 36 inches tall, 2 elements, gives you about 5 dB of gain. And again, all these don't require lightning arrested or DC shorted. What else? We sell the extensions. You want extension cables for the roll up, they're $6 each, normally 8. And then adapters if you want them, the BNC to PL259, so you can adapt the roll up to a mobile. But I appreciate if I'll send you guys a spreadsheet, just fill it out, and then my students will work on it. That's what we do during the week. In fact, you see this room you're looking in is our work room. They come by twice a week and we just go at it. It's basically the job. We don't do it at the university, because if we do, they take away 15%. You can't use university facilities. If you go through them, they have to take 15%. So great, they come over to my house. Works just as well.
These are all your grad students?
That's right. That's
Yeah.
right. Not all. I mean, usually I can employ 2 to 3. I can't employ the whole class, no. But usually 2 or 3 that they're interested. And then pretty much if they come twice a week, it pretty much, we're pretty good at these. It will pay for the room and board and tuition. So basically 2 mornings a week, and they've got their graduate school paid for.
That's a pretty good deal for them.
Yeah, it's a really good deal. It's a really, for them, it's a really, really good deal. We found a good source for good, reliable income. No grants, no fancy grants that you apply and get rejected 80% of the time and all this. This is our business. We know we have a good market for. I've got good customers like ATD Alarms, a lot of commercial folks, Cal Fire, a lot of commercial people buy from us, and we'll customize it, we'll cut it, and we'll do repeater antennas at a pretty reasonable price. So anyway, any questions? Thank you very much for your attention.
So I did have one question. So the
Sure,
difference
sure.
between the DBJ1 and the DBJ2?
Yeah, so this is the base station antenna. The DBJ1 is this one right here. It goes into a PVC pipe for base station, while the 2 is like this. I put it all, in fact, in a Ziploc bag. It rolls up. You can put it in a backpack. In fact, it weighs 6 ounces, everything. And it deploys. You kind of, you just unravel this and you hang it on a branch or something. So it just looks like this.
That's a great soda antenna.
Right, exactly. It's like this. And then here's the little hook. You just throw a rock up a branch and hoist it up, and there you have it. And it gives you about 6 dB over a rubber duck typically. So a lot of people use it. Great for soda, great for camping, great for emergencies. A lot of people use it when you volunteer for doing biking or walkathons and things like that. And they say, oh yeah, night and day difference between a rubber duck. And even night and day difference between, these extended 5/8 ways, a quarter wave antennas, these little whips, like the Comet 771 or a Diamond 771. That's a good antenna, but this one's better because it's a lot tall. It's a lot bigger too, by the way. It doesn't go on your HT, right? You have to hoist it up somewhere. But I hope
And you
Yeah.
you mentioned that if people want to buy like the DBJ1, that we could do that through the club, through you.
through me, yeah. I'm gonna send. Let me send Ken a spreadsheet, and you just have to check the spreadsheet. How many you guys want?
Okay, sounds good.
Yeah, we could do that as
Yeah.
a club buy
Yeah,
and
it's a club buy,
save
right?
some
Yeah.
save some shipping costs and
It's only a club buy that you get a 20% off. Because remember, normally this is a $55 antenna. This is a $60 antenna. You can check on our website. We have a couple of distributors. This is the price we charge. But I have an agreement with my distributors that if I give a talk, I can give it at this price. So you only get it as a club price at these prices.
Ed, I have another question for you for
Sure.
your HF PODA antenna. What do you like to use for a 20-meter PODA antenna?
I don't even compete. I go to QRP kits. You ever hear of them?
No.
QRP kits. Hey, for $25, you can have my business. They make a really cool. I know what's the guy's owner's name? He's really sharp. He's a retired physics teacher. But they design a lot of this stuff. He makes a really good antenna. 25 includes the wire. I mean, wire is not cheap these days. Air resonator. It's a 40-20, and that's usually what I operate. 40 and 20, PODAs and California QSO party. So it's a 40 and 20-meter dipole with traps, but the trap is a really good trap, air core trap, silver mica caps, and I have to say it works really, really well. $25, you can have my business. I'm not even going to compete against you at 25.
All right, thank you.
In fact, you want to see it? I'll bring it here. Hang on. I have it in the other room.
Anyone else have a question?
Yes, is Ed there or is he in the other room?
Yeah, he'll-
Okay, later.
So if anybody wants to buy the antennas, I'll put up a web page on our site, and we can send out an email with the link, and then you'll just be able to sign up through there.
So we can give it a couple weeks, put orders in, and then
Yep.
we can do a buy and get them shipped up here for the next meeting.
Okay. I am back. Hang on. I am coming. Here it is. This is what I put in my backpack. Here's the cool little radio. I got by the QRP kit's really good mic. This mic really, some guy suggested on eHam, get this mic. Yes, it is very good, this mic. That's the radio, 80 through 10, FT8 CW, built-in CW decoder, encoder, all in one, about 5 watts. Battery, and here's the antenna. It just goes in my backpack. It's a 40 and 20 with these really cool traps they made. And I tested, very efficient. And then I use RG174 coax, about 25 feet of it. RG174 at HF, the losses are pretty low. You couldn't use 20 feet at UHF, but at VHF, sure. That's it. I just throw the thing up on a tree and hang it, and you'll be amazed. I typically, my goal in any contest, like California QSO, I can't work all states. That's pretty hard to do. But I do try to work all sections, 0 to 9. And I usually can either do it or come very close to it. It's really lots of fun. Yeah, that USTX radio is really popular here. I show it to folks, and we'll have our flea market and we'll have a booth set up because it's so easy to set up. It's all built in, all the modes and with the mic, and it's so easy to set up. And we start making contacts. And when people start seeing you making contacts at your booth, they say, hey, that's pretty cool. Then they want one. So yeah, it's not something we sell here, but if you want one, I can get it from Ron. Ron KX6AZB does a lot of experiments, and then with a guy named Robert Moffat, another guy, they love to play with this stuff. I let them play with it. I enjoy the results, but that's I think it's for $155. That's a really cool radio.
So we've got a question from one of
Yeah.
our members. Go ahead.
Yeah, hi, Ed. Thanks very much for your talk. I always appreciate hearing from
Oh,
you.
sure.
I live in a high-rise building, and we've had pretty good luck with simple FRS radios using those walkie-talkies inside the high-rise structure. But I'm thinking that your GMRS J-pole could give us an advantage. I wonder if you could comment on the pros and cons of propagation, particularly the vertical aspect. And
Well, most of the propagation, if you're using just handheld radios inside a condo, it's because the stuff's bouncing all over the place.
right, and we noticed you can find some dead spots, but if you just move around a little bit, you'll find some
But
places
yeah,
it
because it's
works.
all the reflections and all that.
That turns out to be a fairly simple principle to
Yep.
inculcate in volunteers. You know, they're able
Yep,
to get
yep.
it and make it work. But it would seem like it's some potential with the GMRS J-pole as a kind of a base station there. And I wonder if you
As a base
comment on
station, yes.
the wisdom of that and any
It will-
suggestion.
Again, the one we offer is a dual element collinear. It isn't a regular J-pole because I figured it was pretty small. You know, it's only 12 inches at UHF, half wave. I've got enough room to have to get some gain. So what it is, it's the one we offer is a 2-element 5 dB gain base station, basically. So if you put it outside, oh yeah, it'll be night and day difference, night and day.
Suppose we kept it inside.
I don't know. Try it. That I don't know.
Yeah, it's empirical. Of course, it depends on location. Thanks.
Yeah, I don't.
Yeah.
I would think if you get it in the middle of the room, what I've noticed with antennas, and a lot of people say, "Oh, I don't have space." Well, why don't you try the antenna? What they find is get it away from the walls, right? If it's too close to the walls, as soon as you transmit, it's being absorbed into the sheetrock and converted to heat. What you want to do is get the antenna in the clear as much as possible, even if it's inside the house. It will work better that way.
Thank you.
But try it. I don't know. Try one of these 5 dB gain ones and just see. I've not done that, but it wouldn't cost you much. It's worth a try. But certainly if you can get it out in the open, oh, night and day.
So another question, Ed, do you set up at the Pacificon conference over in San Ramon next month?
I do not. I am going to be there, but I'll be giving the talk at the Friday night meeting.
All right.
Not about this. If you guys come to the talk of the MDARC meeting, that's the Friday night meeting, you guys are gonna, I think, hear something really, really exciting. Really exciting. I've been thinking about, they kind of forced me to do it.
Oh.
I said, you know, I really, oh, come on, Ed, you can go. It's really hard. I sympathize with people. Don't you guys have a hard time finding speakers every month?
Yes, we do.
Yeah, you should share some with me if you don't mind. 'Cause, oh, we have a hard time.
Okay, well,
Oh, it's really hard. You know,
Well,
if you
we'll
if
give
you
you the
Google-
list of
give me a
speakers
list.
we've had.
Yeah, I mean, I've had, you know, Bob Heil before he passed away, of course, Gordon West, all the famous guys, and I have a lot of my friends that give talks, and a lot of, you know, Tom Lee, professor at Stanford, gives a talk. I don't know if you guys know George Vendelin. When he was alive, he would give a talk, and I end up giving a lot of the talks, and I tell these folks, hey, come on, you guys got to help me out. I don't like to hear myself talk. I really don't.
I had a question
Yeah.
regarding Pacificon. Do you
Yes,
think we could arrange to pick up some of the USDX radios if we come down?
Yes, just tell me ahead of time. Tell
Okay.
me ahead of time. And the antennas, USDX, just have to tell me ahead because I'm not going to be selling there.
Oh, okay.
Just tell me ahead of time, and you'll see me because I'm going to give the Friday night talk. For you
Right.
guys that are engineers or more advanced hams, what the talk is going to be is this. You guys are probably familiar with again, the USDX radio. You're familiar with this, right? The nano. Another really cool instrument that are you guys familiar with these dual trace oscilloscopes? These digital scopes? There's one that's really cool called the DSO 12D3, which means 12 bits, and it's got 3 functions. I don't know if you guys know. Man, my friend Ronnie, he just buys all this stuff. He's a professor at Stanford. He just loves to buy this stuff and show me. Oh, in fact, I'll get one for you. Hang on. Hang on.
Yeah. You never know what's going to come out.
Hey, here's the winner, I think. This is the big time winner. This is an oscilloscope, and I'm going to show it to you. Comes with RF probes, 2 of them, up to 150 megahertz. The scope looks like this. Let me turn it on. But it's just not just a scope. You see the scope,
Yes.
dual trace, color, and it's got, all of these. If you're familiar with these, they have a spectrum analyzer mode. Here, let me show you the spectrum analyzer mode.
What frequency?
Oh, okay, let me tell you the frequency. There's the spectrum analyzer going. So the scope goes up to spect precision 120 megahertz. It's good up to about 150. So you can put in a 2-meter signal and see it in the time domain. So that's pretty good. But it's got a spectrum analyzer mode. Of course, it's got a digital multimeter mode because they just put a chip in there. And it's got a signal generator up to 10 megahertz. All in one. And I look at folks, I go, you realize, so I tell this to my students, you realize 20 years ago, it took a bench to have a spectrum analyzer, dual trace scope, signal generator, and a digital multimeter. That's 4 instruments in your lab. Now the whole lab fits in your pocket for $135. And it comes with the probes. Like, we used to have to pay $100 for the Tektronix probes for you guys that have worked in Tektronix or at HP. These probes were like really expensive. So now the whole thing, if you're more into tinkering and all this stuff, this is an amazing instrument for 135.
That's quite the value. I just,
Yeah.
a couple of years ago, I bought a Rhodes and Schwartz scope. Well, that's 300 megahertz, but it was $1,500.
Yeah. So this is half, 150 megahertz, 135, but it's got a spectrum. It had the FFT mode, I'm sure, right? In it? Yours?
Yes, it does.
Yeah, it has the FFT, so it uses a spectrum analyzer. Again, this one has a signal generator mode and has a digital multimeter mode. See, in fact,
What is the brand and where
so a
can we
lot of
locate
folks
that?
make this apparently. It's called a DSO, digital oscilloscope, O12, which means it's 12 bits, D3, which means it's 3 functions. It's code, yeah. I'm trying to see the exact name of it. Because they're all like this. They're code. DSO means digital oscilloscope, and how many bits and then how many functions.
Great value.
Oh, it's amazing. I carry this in my backpack, It's like whole lab in your pocket. And it even comes with the DC multimeter probes, and it's USB rechargeable. That's the other thing, it's got a built-in lithium-ion battery. So anyway, back to why am I talking about this? People wondered why. You probably wonder why all of a sudden within the last 5 years, you get this USDX, you get the nano, you get these oscilloscopes. There's actually one particular invention that came about. You got see, especially engineers would know this. We were doing op amps for 30, 40 years. Bob Pease, Don Filligard, Denny Montchetti's. And you guys are engineers, you went through op amp theory, designing differential pairs, 741, 709s, all that. That limited things, this is what the Friday night talk is. I'm going to try to make it as non-technical as possible. When you have that configuration, you need several stages of gain to get the gain you want. But then, of course, you have delay. So when you close the loop, it really limits the frequency response. So that limited instruments, if you want high frequency instruments, you need very sophisticated amplifiers with calibration and all that. And that's why network analyzers were $18,000, $20,000, oscilloscopes were multiple thousands of dollars. But about 15 years ago, and of course, UIC designers would know this, the single stage high gain amplifier was reported or configured. Very clever, single stage, and all of a sudden we could do precision gain, 4 or 5 gigahertz, precision gain. we thought this was impossible. We thought this was clearly impossible, but it was possible. All of a sudden, once that was common knowledge to designers, within 10 years, all these instruments are now available, virtually 1/10 of the cost. So I'm just going to go through without the math, the configurations philosophically, how that amplifier works. Because it's unlike the stuff you learned in school. All the stuff, common emitter amplifiers, a common emitter, common base, fine. That was great if you're going at a 741 architecture. But there came a point in time where 30 years of ISSCC papers saying, and we can do this, but none of them was a breakthrough. Yeah, you can improve a little bit here, but none of it was a breakthrough. But about early 2000s, a breakthrough configuration came through where you can actually do a 3-4 gigahertz precision amplifier. And once that was done, you threw it to the systems guys. Wow, low cost. We're talking about in a chip, so pennies. Wow, we can do all these great things. And sure enough, 10 years later, you get all these great things. That's the story behind it. So that's what I'm going to give a talk on Friday night. Come to it. It'll be lots of fun. It's sad because all the stuff you learn, I'm sure a lot of you are engineers, all the stuff you guys learn, it's basically obsolete. See, at some point in engineering, if you've worked on a problem, this is my opinion. If you work on a problem for like 10 years, if it's a new problem, you have a lot of cool ideas. But after 10 years, all the easy ideas are all gone. That's what happened in amplifiers. After 10 years, they did all the whole zero compensation, all the mathematics, fine. But you kept with the same basic path. And it took a total different approach to what is it that you really need in an amplifier? If you need the gain, take away everything else. We don't care about, in fact, the way they designed this amplifier was the applications groups, they said, well, we've come to a wall here. For 30 years, we've been doing the same old stuff and there's no major improvements. And they went back to the fundamental engineers. If you came up with a better amplifier, a real amplifier, then we can make major innovations. And the thing is, this group, and I was part of the group. I wasn't part of the amplifier. I was part of the group. And if you can come, we don't care how many power supplies, whether it uses capacitors for feedback, uses switches, sound, we don't care. Tell us what we need to do. But if you can get us an amplifier that can go to 2-3 gigahertz, then we can make instruments, cheap instruments, that can also go to 2-3 gigahertz. Without calibration. I mean, we had instruments back 30 years ago to go gigahertz, but there were HP stuff, individually calibrated, custom trimmed, and it's not for a consumer. At $18,000, $20,000, $50,000 for a network analyzer, that's basically a university lab type instrument. We want to make it where everyone can afford it. Like a nano, like one of the oscilloscopes. Well, the key was making a precision amplifier to go up to 3-4 gigahertz. So that'll be an interesting talk. I've been working on trying to do it with no math.
We'll look forward to the talk.
So you guys are coming? How many guys are coming to Pacific? That's a long drive for you guys.
Yeah. Well, we've got, we're trying to collect people to go up there and get a block of rooms. And I've been to that show several times as I used to live.
Well, the rooms are all taken. The rooms at the hotel, there's hotels down the street. The reason why is I didn't even get one. I tried to reserve 4 weeks ago. They were all taken at the Marriott's. But that's okay. I mean, there's rooms down the street. I mean, there's a bunch of hotels there.
Yeah.
They're actually cheaper, by the way. They're cheaper and they give you breakfast. So the only problem is this: you got to drive, half a mile every morning. That's not a big deal for me.
All right. Do we
Yeah,
have
excellent.
any other questions? From
questions?
our folks?
Throw me questions. It's free.
Anyone in the audience, the Zoom audience?
Yeah,
Open your mic up.
sure.
I have a question. Thanks for your your talk here, Dr. Fong.
Sure.
I was wondering if you can say something about what you're doing in your lab these days. I know that you've given us a talk about stuff that you put together over the years for ham radio, but are you able to share something about what it is that you're researching?
I do nothing. No,
Thank
no. Hey, I'm 70 years old. I should be retired. I only do fun things. I mean, what I did research was in communications, phase lock loops, CMOS integrated circuits, A to D converters. That was my career. Yeah, really complex. 16-bit converters, and I also did. We had a grant on photo sensors, CMOS photo sensors, depleted photodiodes. That's more academic stuff though. But ham radio, I can, I'm 70, I'm tenure, right? Doesn't matter. They can't fire me. I just teach classes. I
Okay.
don't have to, I should be, I mean, they keep on sending me retirement brochures. Come to the retirement seminar. I haven't gone to one yet, but maybe I should. I don't know.
Thank you.
Hey, well, what else am I going to do, right? This is what you know, what Mark Twain said. If you find a job you like, you never work another day in your life.
True. And there's always the Santa Cruz Mountains to go hiking in. So
Yeah, I go, hey, I've got this site, you know, for the California Cusco party. I got it right in the Santa Cruz Mountains at 17. There's a stream running right at the peak. I'm going to set up my dipole. And the great thing about the USDX, I just have to, it uses a switching RF amplifier. That 4 ampere hour battery will last me all weekend. That's amazing. No extra battery. That's how cool it is. It'll last me all weekend. So yeah,
What,
I just have fun.
What's your what club do you work with down there?
I work with 3. I work with FARS, Foothill Amateur Radio Society, Cathay Amateur Radio Club, and Sunnyvale Amateur Radio Emergency Communication System series.
I have a new ham friend down there that's looking for a club.
Oh, come to ours. Hey, come to ours. I'll email you this September, this 27th was our meeting, 4th Friday. So you're from down here. We are going to have a dinner catered by Tien Fu in Mountain View. John Wang, the chef, is going to make us a really cool dinner, no charge.
Right.
Well,
Well,
if
I'm
they
up in
come, they'll love
Portland
it.
now, but it's my good friend. So I'll
Tell them to come.
Yeah, I will.
You'll love the buffet. This buffet is going to be fantastic. We'll have at least 50, I think 50 or 60 folks there for the food. You don't have to be a ham. See, we look at it this way. You don't have to be a ham. You don't have to be a ham to come out field day. We got to get people in first. If you don't get them in, you got 0 chance of recruiting a ham, right? Get them
That's
in
right.
first. And yeah, if they don't like it, they like the food, that's okay. It's sort of like, you know, real estate, right? You show houses, if you're a real estate agent, most people will not be buying. But you have to show it first for anyone to buy. I can guarantee you, anyone that buys, you show it first. That's the way, the philosophy I look at. You got to get them in. I mean, our field day, we have I've just published, submitted something to AWRS. Are you sick and tired of these field days where you don't get folks? I go, so am I, because when I grew up, we went up in the hills in our backpacks. Like, get out of here. I'm 70 years old. That is not going to be attractive to people. Come on up. Come join us. We have no running water, porta potties. And are you kidding? I'm not going to get anyone. We have ours at our swim and tennis club. Swim and tennis club. This year we had the meal, the Saturday dinner catered by the Pasta Market, an Italian. So Ken would know the Pasta Market. By the Pasta Market, they catered an Italian meal. We have a raffle. Of course, we have radios. We have good whole dessert bar, all free, no charge. But you say, well, how do you do it for free? Well, I got a little trick, right? We have cool raffles. This is what I figured out. By the time they come because it's free, but it's like a gambling casino. You got all these cool USDX radios, a scope. The raffle tickets are $5. Come on. And everyone's having fun. It's like a gambling. Sure. Give me $25 of raffle tickets. And you know, we have never lost money on that. We have never lost money. My wife and I, she helps out. We've never lost money. And then my daughter helps out. She's a ham too. So
Great
hey,
ideas.
swimming, we've got a half-size Olympic pool. It's hot during field day. There's showers there. There's tennis courts. Then we take up the dining hall. So I rented for 2 days, and you figure, don't they charge for it? No, you talk to the board and saying it's for emergency communications. You know, we have fires here. We're going to set up communications, and you know, a third of our people are city workers, emergency communications workers. This is our training drill, and then you convince them, okay, you can have it for free. You just have to know who to talk to. Well, what my wife says, you're a really good sales guy. I mean, you're better in sales than you think you are. But if you talk to the right people, so we have lots of, we I don't know how many were hams, probably 50. We had 85 people sign our log for field day. 85.
Wow, that's excellent.
Oh, they had a hell of a good time. I mean, yeah, I would say who stayed all night? Only about 6 of us, 5 in fact. But for the dinner, they all came. But they saw what ham radio was about. They saw good people and volunteer work and all this, and yeah, it works out. Anyway, I will send you Ken the spreadsheet. And if
All right,
anyone
thank
wants
you.
radios, I'll be at Pacific Con. Just tell me, because I have to tell my friend Ron about the scopes and the USDX radio.
Yeah.
Because I get it from him. Yeah, it's not on our list. I don't do it, but I think there's I fall flat in my face when you say $135 for spectrum analyzer, dual trace color scope, and digital multimeter and signal generator. Amazing. But it's because this all came about because someone came up with an amplifier, a precision amplifier, that you can go up to 4 gigahertz with no tune circuits, no tweaking. That was the key. Anyway, yeah, I'll send you the spreadsheet, and if you guys like to talk, invite me over again. We've got the tri-band. Actually, we've got the tri-band talk. We've got the dual gain talk. I got a DMR talk. And then I guess if you guys missed this talk, I can always give the talk I'm going to give at PacificCon to you guys.
Yeah.
The principal guy.
Do you mind if we put this talk on our YouTube channel for the club
Yeah,
YouTube
go ahead.
channel?
Go ahead. I don't.
Yeah. Okay, good. We'll do
Hey,
that.
nothing's proprietary. At 70 years old, the more I can spread whatever I know, free. Doesn't matter. I mean, if you had talked to me when I was 25, maybe not, right?
Yeah.
But, that's 70. The more hams you can recruit or people get. Hey, the swap meets that I run it with Mike Lechner. And for a while, we were losing a lot of people. The old group. You know what's interesting? I've noticed in the last 3 or 4 years, there's like a bimodal group now. The old folks like me, we run it usually, but we're getting a lot of like younger, more women. They come as groups. They must be engineers working at companies or something to hear about our big swap meet. Are you familiar with the big swap meet we have here?
Is that at the Foothill College?
That's right.
Yeah,
Oh,
it's been
oh,
running
yeah.
for years and for 50 years.
60 years, I think.
Yeah. Okay. I've been there a few times.
Okay. So when I was young, 30 years ago, I used to go to it, and all of a sudden, now I'm running it because they all die off, right? People die off, and you don't want it to go. So they could, oh, Ed, you know this stuff back when you want to run it. So Mike Lecter and myself and some other guys get volunteers, yeah, and it makes good money. We're charging now $40 per seller now. So you can imagine when we run this thing, we pick up about $4,000 every time
Wow.
for the club. It's for so we circulated different clubs, but we basically Mike Lecter, myself, and a guy named Lou. We just kind of control everything. They use my van to ship everything out. Yeah, it's still lots of fun. Still going on.
Okay. Well, Ed, that was a great talk. Thank you so much for.
Oh, you're very welcome.
for
So yeah, if you guys desperate for a talk,
talking to us.
those are the talks I have.
We'll definitely invite you back.
Yeah, just invite me back and just schedule you in because
And-
I know how to, and then share some of the stuff you guys have because I'm always desperate for talks.
Yeah. Okay, we'll do.
Always.
All right.
Only as a last resort do I talk to my club. I mean, it's just not fair, right? It's not fair for me to be. I really don't like to hear myself speak personally. That's not.
All right. Well, thank
Okay.
you so much.
Take care. You're very welcome. You guys see you, and I'm gonna leave. 73.
All right. 7-3. That's part of ham radio. Well, that was a great talk by Ed, and yeah. We'll get a spreadsheet and we'll put some things on the website, and yeah.
So it looks like the one that he's discounting is going to be the DBJ1, which is the sort of like the base station. And I don't think it ships with a 5-foot section of Schedule 80 PVC, so you have to get that. But he includes the end caps. So and you can get PVC at Home Depot for a few dollars for like a 10-foot. But yeah, and then that and you can order any of the others. I think they're just standard price. And what we can do, I'll just put the list up on the website, send out an email. You can just click on the link, and then you can sign up for how whatever you want. Yep. Yeah, so the question was the 5-watt radio looked interesting, and that he doesn't manufacture that, but he said that he has some. Yeah, it's about 150 or so dollars, 155. Yep.
Yeah, that it could. I'm definitely going to check that out because I do a lot of QRP and for that price. And I was thinking that if there was enough orders or interest, we might be able to pick those up at Pacificon, which is next month. Yeah. No, he's just a conduit. Correct. Yes, and that's the key because with a lot of these things, you'll go online, you can see 12 versions,
Yeah.
but you have no idea which one is the right one.
Do we know the model number of that
Yeah,
one?
I know. You and me both.
It was the USDR plus
USDX.
USDX.
Yeah, and I have
Yeah.
heard about that. I haven't seen them, so looks interesting.
The Nano VNA is the same thing. There's many vendors, and there's good ones and not good ones.
But he
So
said that was from qrpkits.com, I think, is where he says saying he got that.
The antenna.
Yeah, the
Oh, I thought it was
antenna
the radio
was
too. Oh.
the dual band 2040 antenna was.
Oh, okay.
Yeah.
Okay, well, we're running a little late tonight, but boy, thank you all for attending.